What would happen if a nuclear bomb were detonated in the Mariana Trench? This is the Tsar Bomba, the nuclear weapon Soviet leader Nikita Khrushchev promised to unveil to the West during the Cold War. 58.6 megatons of raw power with a shockwave that circled the globe 3 times. And this is the Mariana Trench, the deepest trench on Earth's surface, a canyon nearly 11 kilometers deep, up to 5 kilometers wide, and completely filled with water. The Tsar Bomba was dropped from a height of 10.5 kilometers, which is almost equal to the depth of the Mariana Trench. Coincidence? I think not. So, what happens if we drop a nuclear bomb into the depths of the Mariana Trench? First, let's decide to explode the Mariana Trench. Before answering what would happen, we need to figure out a way to deliver the bomb at a depth of 11 kilometers. And it's not as simple as it seems. After all, water density is 1 gram per cubic centimeter, meaning that at those depths, water pressure will reach 110 megapascals, or 1,100 times normal atmospheric pressure. This means that a nuclear bomb with a standard lead outer casing would be crushed without detonating. The result would be a large pancake of uranium, 40 meters in diameter, lying at the bottom of the Mariana Trench, emitting radiation for centuries, since uranium's half-life is 2,000 years. But in this scenario, there'd be no explosion. The charge wouldn't be compressed to the point of critical mass, and the bomb's thermonuclear shell would break down and dissolve in the water before reaching the bottom. So let's say the bomb is lowered within a bathyscaphe, a deep-diving submersible designed to withstand high pressures and controlled remotely. In this case, we get our explosion, and there's more than one way this could play out. If the bomb detonates at a depth of 5 to 8 kilometers, the blast won't be much different from a typical underwater nuclear test, except for a 122-meter tsunami that would appear on the surface of the Pacific Ocean, sweeping over Japan and all of Southeast Asia. Additionally, half of Australia and eastern China would face massive flooding. The Pacific coast of the US, particularly San Francisco and Los Angeles, would be hit by waves up to 76 meters. Other parts of the globe would also be affected, though less intensely. Background radiation in the Pacific would slightly increase for a few days before returning to normal. If the bomb were detonated at a depth between 8 and 11 kilometers, or at the very bottom of the trench, we need to consider that the Mariana Trench is located at the boundary between 2 tectonic plates, the Pacific Plate and the Philippine Plate. If the world's most powerful nuclear device were detonated at this point, the explosive shockwave, amplified by the hydrostatic effect, would exert tremendous downward force, precisely where the tectonic plates meet. As a result, the plates would begin to converge or diverge rapidly, and either of these scenarios spells trouble for humanity. If the bomb explodes at the bottom, we won't just see a massive splash. The energy discharged at the base would travel to the tectonic plate boundaries at the speed of sound. Some of this energy would then reflect back to the surface as a colossal, ultra-super tsunami. Following this, magnitude 12 earthquakes would shake the entire Ring of Fire region, creating a second round of mega tsunamis, even larger than before. A massive release of magma would also occur near the explosion site, triggering a chain of volcanic eruptions. Imagine for a moment that a supervolcano, dormant for millennia, suddenly awakens. In seconds, the Earth quakes violently, signaling the start of a catastrophic event. The initial explosion is so intense that the ground around it disintegrates, and the volcano's caldera collapses, leaving behind a massive crater. As the blast occurs, an enormous column of volcanic ash is thrust into the sky, rising with fury. Millions of tons of ash quickly spread, obscuring the sun and casting darkness over hundreds of kilometers. The particles in the air make breathing difficult, choking vegetation and killing animals. Homes, cars, and anything else in the ash's path are rapidly blanketed in a suffocating grey layer. This volcanic activity would last for at least a month, bringing endless acid rains as ash in the atmosphere disrupts necessary humanitarian air missions and blocks significant sunlight. This scenario resembles a nuclear winter or, at the very least, several very cold years. Combined with tsunamis, this cold could bring about a global catastrophe, placing many species, including humans, on the brink of extinction. Earthquakes follow shortly, shaking the ground with relentless fury. Structures weakened by the initial event collapse, and destruction is visible everywhere. Panic spreads as people desperately seek shelter amid the chaos. In the days and months that follow, the situation worsens dramatically. The local climate is disrupted. Ash and gases thrown into the atmosphere block sunlight, causing temperatures to plummet. Crops fail, and famine begins to spread. Air travel infrastructure grinds to a halt, with flights cancelled and routes diverted to avoid dense ash clouds. Hospitals are overwhelmed with patients suffering respiratory issues, worsened by the inhalation of fine ash particles. The situation intensifies, and public health becomes an urgent priority. There's also the possibility that a Tsar Bomba-type explosion, about 2.5 kilometers from the Mariana Trench floor, could puncture the Earth's crust, creating a magma source that would eventually form a new landmass. This new continent would bring similar environmental challenges and tsunamis as previously described. The colossal impact could potentially push the Earth slightly out of its current orbit, bringing us closer to the Sun and roasting the planet like a second Venus, or pushing us farther out, plunging us into a permanent winter. If Earth's distance from the Sun decreases, the impacts would be catastrophic, affecting all life forms and the structure of the planet itself. Initially, the changes would be subtle, but soon they'd become undeniable. Global temperatures would begin to rise at an alarming rate. Hot days would turn unbearable, and nights, which once provided relief, would become stifling and oppressive. This intense heat would be felt worldwide, sparing few places from its reach. The polar ice caps, usually permanent and imposing, would start melting at an alarming pace. Massive amounts of fresh water would pour into the oceans, causing sea levels to rise rapidly. Coastal cities like New York, Tokyo, and Rio de Janeiro would be the first to suffer, facing severe flooding that would eventually submerge entire neighborhoods. Idyllic islands in the Pacific would disappear beneath the waves, and millions of people would find themselves displaced, forced to flee inland. As temperatures rise, vast regions of the planet would endure severe drought. Forests, deprived of moisture, would become deadly fire traps, ready to ignite at any moment. Epic wildfires would become a regular occurrence, devastating entire ecosystems, displacing wildlife, and threatening human communities. As months go by, the impact on climate and agriculture would become unsustainable. Crops would repeatedly fail, unable to withstand extreme heat and water scarcity. Food shortages would lead to widespread famine, hitting the most vulnerable regions hardest. Desperation would set in as food reserves dwindled, and the once thriving societies would face unimaginable challenges. Finally, there's the possibility that an explosion of such magnitude at a tectonic fault line could simply tear the planet apart. Humanity's fate in such a scenario is easy to predict. Thankfully, the likelihood of any of these events occurring is extremely low. After the successful atmospheric test of the Tsar Bomba in 1963, the countries of the nuclear club signed a treaty in Moscow banning nuclear weapon tests in the atmosphere, outer space, or underwater, a safeguard to prevent future catastrophes.